In light of the present Egyptian comprehensive renaissance and development in all disciplines, the armed forces, represented by the Engineering Authority, established the naval base in East Port Said. Due to the great confidence of the Armed Forces Engineering Authority in EDEX, gained by its previous successful completion of many valuable and strategic projects, EDEX was assigned to construct the eastern pier of the naval base located at East Port Said with a length of 1,000 meters and at a cost of £1,143,000,000, so that it will be able to receive giant warships that have up to 14-meter draft. EDEX was also committed to complete the project in a record time of 18 months. It is worth noting here that this pier is considered one of the largest and most important piers of the Egyptian Navy, as it is located at the eastern entrance to the Suez Canal in East Port Said. EDEX project team has started the preparation of the necessary executive blueprints, obtained accreditation, built the project procurement plan, prepared and approved the concrete mix design. Logistical and administrative procedures have been concluded to include office spaces, vehicles and equipment entry and exit routes, enough lighting and water, signs, and whatever is necessary for the application of vocational safety and health, besides environment-friendly measures. An ambulance vehicle has been made available to maintain the safety of the whole project personnel. Then, the preparation phase started with the soil investigation and geotechnical studies carried out through specialized consultants, and also obtained the related review and approval from the same consultants. This has been followed by soil testing and analysis. Following the soil testing, a topographical survey has been conducted. Some control points have been selected, reviewed, and approved by the consultant. The approved control points will be used as reference points during the project construction lifecycle, enabling us to determine the levels of the work area and estimate the actual quantities of soil required to be removed and added in order to reach the designated level, to determine the levels of the seabed and tidal movements. After calculating the quantities of sand required to execute the backfilling layers, the backfilling process was done by using off-site yellow sand. Heavy equipment such as wheel loaders, excavators, dump trucks, and heavy roller compactors with vibrator, the backfilling was done along with the whole beach length to the level of +1 meter. Then, the subsequent backfilling was done in compact layers by using on-site sand to the level of +2 meters. That was followed by laying a well-compacted layer of base course in a 25 centimeter thickness, so as to be used as a platform for the working area. Subsequently, the location of the guide wall of the 393 membrane walls that would carry 382 Berth piles was identified. With the completion of the processing phase, the construction phase had started. The hydraulic diaphragm wall grab machine excavated the exact locations of the aligned diaphragm wall according to the standard sequence of work by cutting the soil during its continuous vertical descent while pulling up the excavated materials through its strong cutters that cut solid and coherent types of soil, rocks, and concrete. It is necessary during that process that the two sides of the cut have the same rigidity so that the drilling is regular, uniform, and to avoid breakdown of the vertical drilling sides as a result of the lateral pressure caused by the weight of the soil and the loads above it. During the execution of that process, the excavated area was gradually and continuously filled with bentonite, which is a liquid that is slightly higher density than water, to create temporary side pressure equal to the soil pressure and temporarily save the sides of the excavation from collapsing. After each panel was excavated, two steel reinforcement cages were lowered down inside the excavated panel on top of each other and welded electrically to become as a single cage at the same depth of the wall while pumping bentonite continuously. Concrete is then pumped from bottom to top with a density higher than bentonite to drive out the bentonite up and replace it. The hydraulic grab machine working techniques depends on dividing the quay wall on its horizontal axis to almost equal size panels, as the individual panels were executed first. In the next phase, the grab machine executes the other panel in the empty spaces between the casted individual panels. In this phase, the cutters operate in all the sides of the casted concrete panel, which guarantees cutting in a homogeneous way each time. The result is the construction of continuous concrete diaphragm wall with zero joints, very strong to retain the soil and separated soil from water at a height of 63.5 meters and a thickness of 80 centimeters. Simultaneously, the 382 barrette piles are constructed with the same methodology, but it's casted separately, different from the continuous diaphragm wall and according to the design. A hydraulic freeze and grab machine are used for drilling, for which the grab machine is lifted by a crawler crane. The grab machine is equipped with special cutters that is lowered to cut off part of the soil in the width of the hydraulic grab and then raised to empty the outcome of the drilled materials. This process continues with a continuous pumping of the bentonite till it reached to the required excavation level. Drop and fixing the steel cages. Then, concrete is poured from bottom to top in the same manner as the implementation of the diaphragm wall panels, except that the difference in the steel reinforcement details and panel dimensions. The barrette's dimensions are 80 centimeters wide, 2.8 meters long, and 64.5 meters high. Barrettes are regularly distributed as perpendicular axes on the diaphragm wall. Each axis is 22.75 meters long. On each axis, there are two barrettes, almost equally spaced. There is an 11-meter distance between each barrette on the same axis. Axes are distributed in a regular manner, and 5.3 meters are left between each axis to form a matrix of barrettes supporting the berth to withstand the giant mooring ships and tightening them to the pier. The construction system of the pier consists of a front cupping beam, about 2.5 meters wide and 2.5 meters deep, rested on and rigidly connected to the diaphragm wall and is extending throughout the 1,000-meter long pier. And there is a 3-meter wide and a 2.5 meter deep back beam, which is parallel to the front beam and is 22.75 meters far from it, but it is rested on the barrettes of the pier axis. After the construction of the vertical elements completion, including the concrete casting of the barrettes and diaphragm wall elements, as well as the complete hardening of concrete elements achieved, we make sure that the desired comprehensive strength was achieved based on conducting the necessary laboratory tests. Hence, the third stage of construction had started. It started with the preparation of the upper part of pile heads, as well as the top parts of the diaphragm and barrette walls, by crushing their upper part to the required level, which was intentionally poured higher than the required level, as the upper concrete quality is less than the specifications due to the mixing of concrete with bentonite and soil. After preparing the heads, a rebar for the front and back beams will be fabricated, as well as the in-between connected girders. The connected girders are perpendicular to the direction of the diaphragm wall with a length of 22.75 meters, width 1.1 meter, and a depth of 2.5 meters, including 2.1 meters of these girders falls under way wall surface level. The two ends of each connected girder rest on the front beam, for which is the same rested on the diaphragm wall located at the front side, and the connected girder rested on the back beam, as well as the back barrette piles rested on a middle barrette pile. These girders are arranged parallel to each other with a 5.3 meter spacing between them, and they are supported by the barrettes and diaphragm wall. There are 6 girders in each part of the slab between the expansion's joints. The girders are connected in the top with a 40 centimeter thick reinforced concrete slab. To minimize the effect of the internal stresses in the front and back beams, as well as in the pier slab, due to the temperature fluctuation between day and night and between summer and winter, which causes thermal expansion and contraction to the structural elements. Additional rebar is placed, and the pier slab was divided along its length into equal parts. Each part is 32 meters long. Expansion joints of 2.5 centimeters separate each two adjacent slab segments, provided along with the full pier width from the front beam till the back beam, in order to allow free expansion and contraction of each slab segment along with the front and back beams, in order to move freely without any affection to the adjacent segments, so as to avoid any additional stresses. Then a rebar was placed for beams and girders, as well as the embedded fixation parts of the fenders. Bollard and crane rails were fixed in its exact location and at the designated levels. The sides of the prepared framework were fixed, in which the concrete will be poured with the full depth of the beams and girders, except for the upper 40 centimeters, for which the pier slab steel reinforcement have not been yet fixed. The infrastructure works for all water networks, sewage, electricity, firefighting, and all other services are carried out by fixing sleeves, holes, openings, embedded parts in the structural elements at its particular places before pouring the concrete. After dismantling the sides of formwork, the concrete curing and necessary surface treatment and preparation will be done. The waterproofing work will be applied to the beams and gutter sides according to the specifications. Consequently, the backfilling work takes place in between the gutters and beams by using well-graded clean sand, well compacted in layers to the level of 50 centimeters below the final level of pier slab. Once the backfilling work reaches to the specified level, a layer of plain concrete of 10 centimeters thickness is poured, and followed by installing the pier slab reinforcement steel, casting the reinforced concrete to the pier slab, treating and carry out of the necessary finishing to its final surface. After finishing the poured pier slabs, the installation of 100 rubber fenders (62 mooring rings and 4 marine ladders were installed. Moreover, 20 service rooms were constructed on the pier surface. The constructed services rooms has the dimensions of 4.7 meters by 2.5 meters and has a sloped ceiling with a height of 1.8 meters and up to 2.1 meters from the pier slab level. Bricks were made on the sloped ceiling of all the services rooms. In order for the pier project to serve the giant ships, it was necessary to create a service tunnel behind the berth's backyard in order to accommodate the necessary utilities, enabling us to provide the electromechanical works to the pier. The length of the tunnel was about 1,000 meters, which is the same total length of the pier, with a depth of 3 meters and a width of 6 meters. The construction of the service tunnel started with 18,000 cubic meters of excavated sand. To improve the soil underneath the tunnel foundation slab, soil improvement was done by using a mixture of crushed aggregate and sand. Moreover, 1,200 CMC piles were done in order to provide additional way of necessary soil improvement technique, as it is one of the soil improvement methods. The piles were distributed along the service tunnel length. The formation level prepared and well compacted, and plain concrete base was poured with a width of 4 meters and a thickness of 15 centimeters with a total quantity of 600 cubic meters. Then the trench reinforced concrete base was poured with a total quantity of 1,175 cubic meters, and 3 reinforced concrete walls were constructed in a height of 1.8 meters. During the walls' construction simultaneously, the precast reinforcement concrete covers were done in order to fix these covers to the service tunnels once the desired comprehensive strength of the same were achieved. The concrete covers were divided into 496 NOs with a length of 2 meters and 116 NOs with a length of 6 meters in order to facilitate their transportation, handling, and fixation process. A rubber strip with 0.5 centimeter thickness and 1 centimeter width was fixed to the trench wall top prior to lay the precast concrete covers in order to decrease the friction in between the joint area. During the construction of the quay wall, it was our obligation to protect the existing east pier port of the naval base and provide the necessary entry paths and maneuvering area as required to the giant ships. edX has installed the wave and marine barrier protection with a length of 2,451 meters and removed the existing 550 linear meters old barrier from the naval base located at Eastport Said. The wave and marine barrier protection were installed in 2 directions simultaneously, as it is mandatory requirement to facilitate the project execution and completion according to the agreed milestone. At the beginning of the project, the stone storage yard was established. The stone stockpile will be used in the construction of the water barrier, whether from the east or the west. The stone samples have been approved according to the project specifications. A primary survey of seabed levels were carried out along with the sections of the water barrier intended to be constructed. This was followed by the process of placing the stones from the east and west sides according to the project specifications, proved samples, and agreed methods of statement. This process was executed and completed on 3 phases as follows. Phase 1. It is the water barrier core layer. Demarcation done to determine the axis and border of the core layer. Consequently, and by using the necessary surveying devices, the placing process of stone with weights from 20 to 200 kilograms was commenced and completed. Phase 2. It is the filter layer, which was implemented from the seaside by using stones with weights from 300 to 500 kilograms for each sector separately. The stone placing process was done according to the designated inclinations and periphery surface borders. Phase 3. It is the protection layer, which was implemented by using stones with weights from 500 to 2,000 kilograms for each sector. The execution of its front area done in the beginning as per the approved levels and dimensions. Consequently, the final slope adjustment done by using the long arm excavators. To facilitate the passage of the trucks, cars, and maneuvering area of the equipment, we have temporarily established a roundabout every 50 or 100 meters by increasing the width of the water barrier, and the same was removed after the construction completion in reverse way. To make an entrance to the port and facilitate the entry of giant ships, the old barrier stones were removed and reused in the construction of the new barrier according to their size. This process was done by using the long arm excavators and dumbers. After the barrier layers are completely finished, the construction of concrete slabs commenced over the barrier stones. The necessary formwork installed. The concrete casted in segments-wise. Expansion joints provided at every 21 meters length, with an overall 117 NOs of expansion joints. Consequently, the shoulders had been established on the side of the slab with a height of 2.4 meters. Then, the stones were placed behind the girders after pouring shoulders were completed. The role of edX wasn't limited to the construction of the pier and quay wall, but it extended to the construction of all the internal roads of the naval base. During the project, edX provided a big workshop for the preparation of reinforcing steel that contains more NOs of bars cutting machines, bars bending machines, welding machines, trailers, mobile cranes, forklifts, etc. in order to fabricate the steel reinforcement cages that shall be used in the diaphragm wall, barrette piles, core pile, beams, girders, and slabs. The total quantity of the high tensile strength steel bars used in the project have exceeded 30,000 tons. edX has built 2 batch plants that were used throughout the project, with a total production volume of more than 150,000 cubic meters. The company commenced the project construction period in August 2018, and the project was completed in November 2019. The project was completed in 15 months, 3 months ahead of the contractual deadline, which is unprecedented rate for the implementation of this type and size of piers in Egypt. Challenges to overcome the project constraints in respect of time, quality, and safety were the main great catalyst for edX team to execute this giant project in a record time, seizing the opportunity of the existing pioneer experience and talented management system at edX, work plan prepared and enough resources procured, working continuously in successive shifts for 24 hours a day, 7 days a week, under all weather conditions, in order to overcome all the expected difficulties through edX competent and proficient engineers, well-trained workers, supportive and proactive management team possessing a very long experience and reserve unique goals, achievements, and successes. edX, speedy performance and strong construction.